Hello everyone, my name is Boros, I'm Principal Architect for Percona, and today I will talk about swapping out MySQL with Percona Server for higher performance. I will talk about what is Percona Server, what benefits does it give you, and I will talk a bit about us first. Percona is the oldest independent MySQL support consulting and remote DBA company. We exist since 2006, and we have a global 24/7 staff. We produce open source software based on the knowledge we gain in our services. So most of the improvements I will show in Percona Server are driven by real-world needs. So we saw problems that could be solved by changing the server code itself. And it's important also that all Percona software is open source. And we saw many use cases and application to use our database at the core of OpenStack. For example, for database for Nova. What kind of open source software do we have? We have Percona Server, which is an enhanced version of MySQL Community Edition. We have Percona Extra Backup, which is a free and open source hot backup software for InnoDB for non-blocking backups. We have Percona Extra DB Cluster, which is latest Percona Server plus the latest Extra Backup plus the latest Galera. And we have Percona Toolkit for MySQL, which is a set of tools which eases day-to-day operations with MySQL. Again, Percona Toolkit is made in a way that when we see issues repeating, we kind of automate them, and these will be sooner or later part of Percona Toolkit. Okay, so what is Percona Server? Percona Server has some general performance improvements, and one of the greatest benefits is, or are the improvements on observability. We have extensive diagnostics in table user and index statistics and information schema, and we also extended the slow query logs. For example, we added microsecond precision in slow query logs in the very early days. We also have a thread pool plugin, and a pluggable authentication module plugin, which are add-ons in MySQL Enterprise. And also, we have integration with Percona Extra Backup in a way that it's possible to have real incremental backups on Percona Server because we are capable of doing archive logging and archive log backups. We have statement timeouts, so you can set a timeout to a statement, and if it doesn't complete in that time frame, it will be just thrown back. And we are fully drop-in compatible with MySQL. So if MySQL worked for your OpenStack deployment, Percona Server will work as well. Some more details on what did we really do, because I said that we have performance enhancements, right? But everybody says that, so. Let's go into a little bit of more details. So MySQL 5.6 is a great release, and the engineering focus there was on the case where the data fits in memory. And our research showed that further improvements can be made for I/O-bound cases. And instead of talking about numbers, I will show you, or just numbers, I will show you a benchmark. Or a few benchmark results which will tell you about consistency. This benchmark is Sysbench, which is a very widely used benchmark in MySQL community. It has 32 tables, 10 million rows in each table, 77 gigabytes of data on a 25 gigabyte of buffer pool, so the data does not fit in memory. And it is on fast PCI Express storage, which is capable to perform more than 100,000 IOPS of 16K random writes. Okay, InnoDB's default page size is 16K, so this is why 16K IOPS performance is important. And we are using 250 user threads, so this is a massively parallel workload. And here is the graph. So this is Sysbench transactions per second. The red one is MySQL 5.6 Community Edition. and the blue one is Percona Server. So you can see that the sustainable rate for MySQL is around 3000 TPS. A sysbench transaction contains 14 queries. So for Percona Server, it's almost double. Also, this is a scatter plot. So each individual dot here is a sample from a second granularity output from a sysbench. So how wide the graph is tells you how consistent the performance is. And Percona Server's performance is pretty consistent. It's really important for us that, you know, in real world, you don't want to have nice spikes and nice peak performance. It's important what you can actually sustain. And the case is similar for the response times. Here, the lower is the better, right? So our response time is much more consistent. Okay, thank you for listening, and thanks for the sponsors, HP, Rackspace, and Cisco, for making this possible.